This is Dr. Lennon, and this is the Module 1 homework on STAT. So we'll go through this. I will note that this homework is kind of fundamentally different than the other 6 modules and final in the course because mostly this is a module that tests terminology and basic just definitions, examples. In the forthcoming modules, we'll see a lot more computation using our software tool StatCrunch, which is one of the options under Get More Help. But we won't really use that in this module. We'll mostly use the textbook. I will say, try to avoid using this Ask My Instructor. Email me directly because I don't think this is set up to go to my personal email. So if you click it, it might not end up going to my active account. But on something like this, basically, this first homework is 22 questions and mostly just multiple choice. So for a lot of the stuff in here, you can find the source material in the textbook by going to Get More Help and going to textbook. I believe it'll bring you to the section, but may not exactly bring you to the specific spot, but you can go ahead and do that using a quick search. So yeah, it takes you to section 1.1. So in the textbook, if you wanted to figure out what like a census was, you could go to search and type census, and I believe it doesn't show anything there. Let's see if we go to pages. This is the first page. Okay, we have the definitions. So we have the definitions of census right here. So maybe if you do Control F, it'll let you search. So usually that'll let you search on the page, but it's not coming up for me. Maybe you'll have a bit more luck. I'm not sure. If we display settings, we see some options here, but maybe double page is a little more useful so we can see more. It doesn't look like it fits all that well. Maybe if we zoom out, let's see. So yeah, we can zoom out and see a little bit faster there. For whatever reason, it doesn't start on the table of contents. It starts right in the middle of the text under chapter objectives for section 1. So nothing too earth-shattering there, but the definitions for 1.1 are what we need for this first question. So let's go ahead and leave it there. So we've got this scenario and we want to answer the question. So it says in a survey of 729 subjects, in your questions you might have different numbers. The following was posted. In your view, are nuclear plants safe? The survey subjects were internet users who chose to respond, posted on the electronic edition. So a lot of times what we're going to learn in stats is our data is going to be only as reliable as the methods that are used to collect it. So one of the important things for us is a simple random sample. When we're trying to make inferences about a larger population, we want to make sure that we have unbiased data. This example is biased because only people that are choosing to respond are the ones that do so. So this is what's known as a voluntary response sample. So it's going to be flawed. Statistically significant is going to come up more when we're actually doing some computations. Census is never going to be flawed. That means you're actually taking information from every single person in the population. Usually the problem with census data is it's very cumbersome and requires a lot of resources. So usually one of the goals of stats is to try to look at a smaller sample and capture some information about larger populations so you don't have to go through the trouble of creating a census. And again, we see it's biased because it's voluntary response. Self-reporting is a prime example. Okay, so let's move on. So observational study versus experiment. A lot of times when we're dealing with humans, we can't do experimentation because of ethical concerns and other reasons. But the difference mainly between an observational study and an experiment is an experiment has a control, meaning one group is being tested that has a treatment and the other one is given a placebo treatment. Whereas an observational study, you're just kind of observing what's going on, but you're not able to prescribe a prescription and a control. So let's see what's going on here. Sometimes these are a little bit tricky because they don't exactly give you as much experimental design as you might be given access to if you were really trying to conduct an analysis of an experiment. But it says research is conducted to determine if there's a relation between stomach cancer and alcohol consumption. Okay, so if it's research being conducted, it doesn't look like there's any treatment here. This would just, I think, be an observational study because, like, you're not going to prescribe someone to drink alcohol. So let's say observational study. Maybe I'll get it wrong. I miss these often because it's not so clear how it's being conducted. Yeah, but they're not talking about a particular treatment to the stomach cancer and then the other group not receiving a treatment. Like if you looked at people suffering stomach cancer and you gave one the standard treatment, that would be like the placebo, and then you gave another one an experimental treatment, that would be an example of experimentation. Okay, all these are different kinds of sampling, and we have the definitions of those somewhere in the section 1.1. So let's see if we can find that to help us. A lot of them you can. Systematic is just like a rule that you create that samples maybe like one every 10th survey received, something like that. Random might be created using any kind of pseudo-random algorithm by a computer, or even atmospheric noise, something like that. Convenient sampling might be something like creating a Facebook survey, something that's just easy to do, going door to door in your neighborhood. Cluster sampling and stratified sampling looks at subdividing populations of samples that you have. So let's see if we can figure out where those different sample types are. So maybe it's in the next section. So let's go ahead and try to get more help and open the textbook and see if it gives us a different section. You can get to the textbook from going through StatCrunch, yeah. So this is in section 1.2 or 3, where we're starting to talk about placebo. Okay, so the difference between experiment and observational study we also talked briefly about, and then here's the different definitions of the samplings we see. So stratified, we're subdividing the population into two different subgroups with similar characteristics, and then we draw a sample from each. With clusters, we're choosing all the members from specific clusters. Okay, so that's the difference, but still you're dividing the population in both of these types. Okay, so a man's conducting a marketing company to participate in a paid focus group. The company says the man was selected because his name is among the first 300 in the phone number listings. To me, that sounds convenient. Definitely not random. It's just the first 300 they looked at. Not very systematic either. So I would say this is convenience. Okay, this one, again, we're asking the same types of thing. This is the one I talked about when I gave an example of systematic. He is selecting every 17th computer that comes off the assembly line for quality control. So that is just a very basic systematic way of testing only a portion of the population. Okay, this one we have a woman experiencing a tax audit. The department claims she was audited because she was randomly selected. Okay, if we take their word for it, we're just going to say that's random sampling. We have no means to see how they conducted the sampling, so sometimes people will say something's randomly sampled and it may not be, or it might be pseudo-randomly sampled, but that's probably a bit beyond the scope of this course. Okay, the histogram here, what this is doing is this is dividing groups based on each weight category. Sometimes these things are a bit silly, like you wouldn't really care about the weight of members of a debate team, but that's what we've got here. So each height represents the number of people. So they're asking basically how many people are on the debate team. So basically you're just adding the height of each bar. So we've got 5 plus 2 is 7, plus 1, 8, plus 1, 9, plus 4, 13, plus 5, that brings my total to 23. So you're just adding the heights of all the bars there. Okay, what is the class width? Well, the class width is just the difference between each of the bars. So basically, anybody in group 1 is between 100 and 120. So the width is 20 pounds. Similar for each of the other bars. 120 to 140 is 20 pounds, 140 to 160 is 20 pounds, etc. So the class width is the 20-pound difference between the bottom of the bar to the top of the bar. Okay, what's the approximate lower and upper class limits of the first class? Let's make sure. If this whole thing is the first class, it would be 100 to 240. But if we're just looking at the first bar, it would be 100 to 120. So that's just what I'm trying to see. Represent the weights. What is the class width? What is the lower and upper class limits of the first class? Let's say it's 100 to 120 and see if that's what they want. To me, that seems what it looks like, although they're kind of using the word class a bit freely there. Okay, again, histograms here. Just quickly, you can always tell a histogram versus a bar graph by the bars being adjacent to each other as they are in A and D, whereas bar graphs are B and C because there's space between the bars. What that indicates is that bar graphs are given qualitative data along the x-axis, meaning that there's no numerical data that's being used to subdivide them, whereas A and D would be using numerical data. Now, because this data, you might look at the letters and say, oh, this is qualitative, but each class A, B, C, D, E, F, G is actually assigned to specific numerical values that we could classify as numerical. So, and they also say the word histogram. So we can immediately rule out B and C because B and C are not histograms. So we know it should be either A or D. Let's just look at D. D looks like it's about 12 or so, 13. Okay, so letter D doesn't make sense here because it's a very low number. So our answer should be A. Does it have a distribution that's normal? Normal's like a bell curve. So if you drew a curve, you have the small tail ends toward the left and the right, and then the cluster of data in the middle. So this looks like a bell curve. So A is approximately normal, is correct. D is not. D is right-tailed because it's skewed to the right-hand side. Okay, so I was incorrect. We can actually do some StatCrunch stuff here. So we're going to do some computations. It's asking us for the mean, median, mode, mid-range. The mid-range is not something StatCrunch can do, but it's not hard. It's just the min plus the max divided by 2. So let's open this data in StatCrunch, and I'll show you how to do it. So let's split screen this. So what we want to do here is all of our data is populated when you open it from the little box in variable 1. So we go to stat, calculator. No, we want to do summary stats. So stat, go to summary stats by column. We're going to select variable 1, and then you want to pick the statistics we want. So let's do them in order. So mean, if you want to select multiple, you want to hold the control or command key on your keyboard. So we select mean first, and then let's go and find median. Select that, and then we also want the mode, and then we want the min and the max. The min and the max are used to compute the mid-range. Okay, so we can click compute. Oh, I must have left off the control key. I lost some of my numbers. So we want the mean, the median, mode, the min, and the max. Okay, let's compute. I forgot to select variable 1. Okay, so now we have our values. So always pay attention to how many decimals it asks for. So in this case, it's going to be 64.3 when we round to one place. The 7 bumps up the 2 to a 3. And then the median is 74. That's the middle number when you order the data. And then there's no mode, which means no number is repeated. And then the mid-range, what you want to do is you want to add the min and the max and divide by 2. So 9 plus 99 is 108, and 108 divided by 2 is 54. And that's how you get the mid-range. What did the results tell us? Okay, so the median is a measure of center that's less influenced by outliers than the mean. So because the mean is so much lower than the median, that means that there are more low outliers in this data set, which means the mean is being pulled in the direction of the low numbers. The mean is more sensitive to very big or very small numbers. It's going to be pulled in that direction. So maybe that's not what they're asking for, but that's just one thing I thought I'd point out. Also, if these are Jersey numbers, typically Jersey numbers don't represent anything meaningful. Yeah, the Jersey numbers are nominal data. They're really just naming the players in a different way. They don't measure or count anything. So this isn't doing anything in terms of measurement. So we'll select D as our answer. Okay, same thing here. We want to open the data in StatCrunch and then go ahead and just do the summary stat by column, select variable 1, and then we want the same exact things. We want mean, median, min, max, and mode. Compute. Again, your numbers are going to be different than mine, but the same procedure is going to work. So 3 decimal places for my mean is going to bring me to 0.865. The 5 after the 4 in the 4th decimal place position bumps that 4 up in the 3rd. The median is just 0.91. If it asks for 3 decimal places and it only gives 2, then you just put in the 2 that you have. The mid-range, we add the min and the max. Let's just go ahead and get a calculator out, because it's going to come out a little bit. So 0.25 plus 1.56, and then we divide that by 2. We get 0.905. It says 3 decimal places, so we do use them all. And then lastly, the mode. It says no mode, so we have no repeated numbers. Usually if we have lots of decimal places, mode is not going to be very common to use or see. This is talking about cell phone radiation, and it says it's dangerous if it's 1.6 or more. So the max is what we care about because it's going to be the closest to that value. So the maximum data value is the most relative because it's closest to 1.6, this 1.56 number, and that's the one we want to try to avoid. Okay, we're looking at college tuitions now. Again, just different numerical data, but the same thing. They're asking for all the same numbers, so we go to stat, summary stat by column, select variable 1, select the mean, median, min, up. Forget to hold control, it's a whole, gotta start over. And the mode. I know one of these eventually is gonna have a mode, so we'll see that come up. Yeah, we finally got a mode, 52,612. Okay, so the mean here is 52,378.1. The median is 52,521.5. 52,521.5. Type an integer or decimal rounded to 2 decimal places. If there's 10, it should be that value. We got the mean right. How could we get the mean right and not get the median? Okay, let me try again. Stat, summary, column, variable. Maybe I did it in the wrong order. Mean, median, min, max, and mode. We'll do it by hand to double check if we get the same value. 52521.5. So what is that? 2 decimal places? So if we order the data, we could look at our 2 middle numbers. So if we go from smallest to largest, the 2 50,000s are the smallest. And we've got 5151. Okay, so then we have 3 numbers in the 52 range, which are representing our middle numbers. So we want to take the smaller 2, 52431 and 52612. So if we do 52431 plus 52612, and then divide that by 2, that should give us our median, 52,521.5. I can do 0.50, but I don't know why that would make a difference. 52,521.50. So the 10... If the 10 most expensive colleges are there, it should be the average between the 5th and the 6th largest values. 50, 50, 51, 51. This one and then this one. Are they rounding and then doing it or something? I'm not exactly sure. Oh, they were asking for the mid-range. Oh. Fiddlesticks. So it was in the wrong order. I was typing in the median. So the median will be this number. So the answer for the mid-range should have just been the max and the min divided by 2. So if you do 54492 plus 52612 divided by 2, that'll give you the answer. So that's my mistake, but I'm still getting something slightly different. Oh, I added the mode. Sorry. So a lot of numbers. We should be adding these 2 numbers and then dividing by 2, and that should give the answer. So let's just try that one time. 50,580 plus 54,492 equals, and then divided by 2. Okay, and then that gives us our answer of 52,536. So sorry about that. I completely just ignored the word. I was doing it in the same order because the problems before all went median, or went mean median. This one goes mean mid-range. Okay, so the mode is 52,612. And since it's the top 10 list, this isn't representative of all colleges. This is representative of the most 10 expensive colleges. Yeah, so it's not telling you anything about all colleges. It's just telling you about the most expensive colleges. So it's not representing all colleges very well. Okay, on this one, we have two different populations, so we're going to open the stuff in StatCrunch, and we're basically going to do two sample summaries. It asks about the mean and the median of each one. So what we want to do is do summary by column, and we want to do each one. Let's see if we can do both. Let's see what happens if we select security company, other company, mean, median, and then compute. See if it gives us all four. Yeah, it does. So we've got the mean of the security and then the mean of the other companies. This one's actually kind of funny because I think the conclusion is that the security company has somebody embezzling money because it's doing so much worse than the other companies. But the mean for the security company is 1.47 million, and for the other companies it's 1.91. And the medians are 1.5 and 1.9. So very close, the medians and the means, but the security company is doing much worse than the other ones, the one that we're investigating. So the mean and median are both lower is what we want to see. Yeah, so that's A. So if we're an accountant, that's going to be a little bit fishy. Yeah. So C, since it appears to be lower, then it shows some evidence of stealing at some point. So this is often what they do in forensic accounting, is look for oddities like this and then investigate. Again, this is something from the textbook, but it's pretty simple. For sample sizes, we use regular letters, and for population parameters, we use Greek letters. So for standard deviation, it's just S. For population standard deviation, it's sigma. So that's the Greek letter sigma. For sample variance, it's just the square. So it's S squared for sample. For population, it's sigma squared. So standard deviation is unitless measurement. So this one's actually kind of like a trick question. It basically tells you what percentage of data you're capturing on certain distributions. But ignore all of this stuff and just select the empty one, which is kind of weird to think. So for standard deviation, population standard deviation, you've got this. Oh no, but it tells us in grams. Sample data consists of weight measures in grams. So maybe it's G and G squared. Typically, it's not going to be that. Let's just check this real quick and see what happens. Yeah, usually standard deviation is interpreted in the context of percentages of population captured, but okay. The important thing to realize is variance is just the square of standard deviation, or you could think of it the other way. Standard deviation is the square root of variance. Okay, so the range here, this is not anything complicated. This is just maximum minus minimum. So if you look at the highest net worth, the highest is Oprah at $3,200, and the lowest is Jerry Seinfeld at $950. So on a calculator, we can just do 3,200 minus 950, and that's going to give us the range. So the range is just max minus min, and we see that here is 2,250. And it just wants it as an integer, so that's exactly right. Pop that in, and we get the right answer. Okay, the variance is a little more complicated. To do the variance, what we want to do is we want to open that data in StatCrunch. Again, anytime you see a little rectangle like this, you can open that data. So let's open that in StatCrunch. And it asks for the variance and standard deviation, so let's just do that. You can probably also do the range, but let's just go to summary stat. The range is easy enough, so I just did that by hand. But let's do the variance and the standard deviation now. Click compute. Remember to select the numerical column. Okay, so the variance is this very big number, 76441, and it would be 6, but it says nearest integer that rounds to a 7. So we get that value. and then the standard deviation is just 874. Okay, what does it tell us about the population of all celebrities? Again, this is not great because this is not representative of all celebrities. It's just representative of celebrities with the highest net worths. So it's a similar problem to the highest tuition question. Yeah, so because I would say A, it's typical for those from the highest net worths. It's atypical of variation in all celebrities. We're basically just looking at billionaire celebrities. Based on the nature of the amounts, what can be inferred? Okay, they all end in 1-0. So let's see, this is 100 million, 10 million, million. So that's in millions of dollars. So because all the amounts end with 0, it appears they are rounded to the nearest $1 million, so it would make sense to round results to the nearest. Let's say $1 million. I feel one of them might be tens of millions. Yeah. It said first and third are correct, so that means these are given in tens of millions. That's measured, so we're measuring in millions. So I remembered that. I just wanted to double check. Okay, again, this is numerical data, but it's really categorical. So they're using numbers to just represent colors here. So the range of the sample data, the biggest number is 4, the smallest number is 1. So the range would be 4 minus 1, which is 3. But again, this doesn't really make any sense because you can't subtract colors. Can we actually do standard deviation here? We probably can. But again, it's not going to be very meaningful. So let's open the data, just do the summary stat with standard deviation. So we can select this, do standard deviation, but what is it going to measure? I mean, it doesn't really make sense. So it says 1 decimal place, so 0.7 would be my answer here. But again, commons and variance we could also do. So if you've already done it and asked for something else, you can do options edit and then just select something else and do the computation again instead of starting from scratch. So this is 0.4 now. Again, yeah, so the data is nominal or categorical or qualitative. Any of those words are basically the same. So I'm going to select B. It doesn't make sense to try to compute anything with these numbers because they're really just representing categories. Okay, so we've got some blood pressure numbers here. This makes sense. The coefficient of variation, how do we find that? Let's see. I don't exactly remember off the top of my head, but I'm sure it will come to me. Find the coefficient of variation for each of the 2 samples, then compare. Okay, so let's just do summary stat again, column. Select each column, hold control to select multiple. Let's just see if it has coefficient of variation here. Yeah, coefficient of variation. So it's just a number that we compute here, and it's being interpreted as a percentage. So the systolic is the higher number, or the first column. So that comes out to about, it would be 14.9, but the 7 bumps it up, so that's really 15.0 once we round. And diastolic is 17.1. And the coefficient of variation is less. Not much less, we'll say about the same. So they vary about the same. Yeah. So we should expect that they kind of move or have a positive correlation with one another. Okay, same thing here. We've got mean wait times at 2 different banks, but basically the same kind of question, just in a different context. So we go to stat, summary, by column, select both columns, and then we want to look for coefficient of variation. Find that value. Okay, so we've got these, this time it is a bit different. So 6.9 for the first value, and then the next value is 24.8. Is there a difference? Yeah, I would say there's a significant difference. B is much. A single line seems longer in general, but let's see. No, there's more variation. So there's, yeah. The waiting times are much different in bank B than they are in A. A is more consistent. So the waiting times in A have less variation than the waiting times in B. Okay, so z-scores is just telling you how far away you are. So basically the way to compute a z-score is you do observation minus average divided by standard deviation. So basically, if you were exactly average, you would have a z-score of 0. If you were 1 standard deviation above average, your z-score would be 1. 2 standard deviations above would be 2. So if you think about it kind of like on a, let's say, your grade point calculator, like if it were a uniform distribution, meaning you had the same number of people scoring each letter value, then you'd have an equal number of Fs, which would be 2 standard deviations below. Ds would be 1 standard deviation below. C would be average. B would be 1 standard deviation above, and A would be 2 standard deviations above. So you would want a score of 2 standard deviations above. So a z-score of 2 would be preferable. Okay, to compute a z-score, what we're going to do is we're going to do the value minus the average divided by the standard deviation. So we have, let's just get a regular calculator out. So to find the z-score of the tallest man, we would want to do 231 minus the average, which was 171.35. And then we want to divide by the standard deviation, which is 5.74. And we get 2 decimal places to 39. So 10.39, that would be the z-score for the tallest man. For the shortest man, we're going to do the observation, which is 130. 130.4, so 130.4 minus the average, 171.35, and then divide by the 5.74, and we get negative 7.13. And so the more extreme score is the one with the higher absolute value. So the taller man was the larger extreme. Okay, so again we're doing z-score here for extreme male versus extreme female. So let's do the male. 1700, so 1700 grams for the male, minus the average, which was 3232.6. And divide by the standard deviation, 532.9. And we get negative 2.88. For the female, so we're going to do that value, which is 1700, minus the 3079.6. And then divide by the standard deviation here, which is a larger number, 711.8, and we get a z-score of minus 1.94. So the male has the more extreme z-score in this example. Okay, this is the 5-number summary. The 5-number summary is very similar to what we've done. It's just min, Q1, median, Q3, and max. So we just find those 5 numbers. So let's open the data, compute those 5 numbers, and then basically we're all done. Part 2 will probably be locate them on a graph, which is just basic identification. So stat, summary stat by column, variable 1. So let's try and do them in order. So we want to start with the min, and then do Q1, and then the median. Median is Q2, Q3, and then the max. So another way to think about this is 0th percentile, 25th percentile, 50th percentile, 75th percentile, and 100th percentile, or 99th percentile. I don't think you can have 100th percentile technically, because you're greater than 99% of all observations. But okay, so then we just fill in those numbers exactly as we see them. 120, 126, 129, 140, and 150. Okay, check answer. Okay, so which one makes sense? Let's just try to identify some of the numbers. So 129, so basically your numbers go end of the line, and then end of the bar is Q1, Q2, excuse me. So min, Q1, median, Q3, and max. So this looks like about 129, 129, 129, 129. So all the medians look kind of okay. C is probably not okay. All those look like they're at 150. What about Q3? 140. B doesn't look right. A doesn't look right. D is the only one that has Q3 at 140, so D looks like our answer. Okay, our last one, we're doing a box plot. We have to open all this data and then construct a, again, 5-number summary. Okay, so men's pulse rate, probably they'll ask us to do both, so let's just go ahead and do summary stat, and let's do both of them. So select men and women, and then let's try to do this again the same way. So select the min first, and then Q1, and then the median, and then Q3, and then the max. So we compute. We have all of our relevant numbers. First they ask us for men's, so let's just look at these values. So our median should be about 66.5. So that median's too big, it's over 70. That median's over 70. That median looks about right. This median looks about right. How are these graphs different? Well, this one has a max of about 95. This one has a max of about 89. Okay, so we see the max is really 89 for men, so that should be D. Let's look at the women. So our median should be about 77. This looks like it's 80, too big. That looks about right. That looks about right. This is too small. So we're between B and C. Are their maxes different? We have 105 as max here, and we have 105 as max. What about our mins? Maybe 57 here. Maybe 67 here. So what's our min? 58. So B looks like a more reasonable choice. Okay, so in general, it looks like the pulse rate of men is a bit lower. What about the variation? Did we compute the variation? We did, and let's see what the options are. So men have lower pulse rates. So it could be A, B is wrong, C is wrong. It could also be D. To me, it looks pretty similar. It just looks like women are skewed up by about 10 beats per second, so I would say D. Men have lower pulse rates, but they're pretty similar. Yeah. Okay, so that's it for the first homework. So hopefully that made sense. The first half basically looking at definitions from the textbook, and then the second half doing some basic summary stats from StatCrunch. Okay. Good luck on the homework when you do it. Thanks.